Hello learners. In this lecture we will study determinants and properties of determinants. Definition of determinants. For every square matrix C is equal to Cij of order n into n, a determinant can be defined as a scalar value that is a real or complex number, where Cij is the ijth element of the matrix C. Here the determinant is written by taking the grid of the numbers and arranging them inside the absolute value bars instead of using square brackets. Let ax plus by is equal to 0 and cx plus dy is equal to 0, then determinant will be ad minus bc. Characteristics of determinant. From the above definition, the essential characteristics of determinant may be analyzed as under. It is a numerical value. It is obtained from square matrix. It is obtained from the coefficients of certain unknown variables, say x, y, z, etc. It is obtained from square matrix enclosed by two bars in the left and the right hand sides. It has a large number of algebraic properties. Cofactor and minor. By the minor of an element of a determinant, we mean the subsquare determinant of the given determinant along which the particular element aij does not exist. It is obtained by deleting the row and the column on which the particular element aij lies. It is represented by mij, which denotes the minor of an element in the ith row and the jth column of the determinant. Its value is obtained by deducting the product of its non-leading diagonal elements from the product of its leading diagonal elements. Cofactor. By the cofactor of an element of a determinant, we mean the product of -1 to the power I plus j and the minor of the concerned element mij. Symbolically, it is given by Cij is equal to -1 raised to the power I plus j multiplied by mij, where Cij is equal to the cofactor of the element in the ith row and the jth column of the determinant. Properties of determinant. If any row or column of the determinant consists of zeros, only the value of a determinant becomes 0. If any two rows or columns of the determinant are identical, then the value of the determinant becomes 0. The value of the determinant remains unchanged even if its rows and columns are interchanged. If any two adjacent rows or columns of a determinant are interchanged, the numerical value of the determinant remains the same but with the opposite sign. If every element in a row or column consists of the sum or difference of two quantities, then the determinant can be expressed as the sum or difference of two determinants of the same order. If each determinant in a row or column of a determinant is multiplied by the constant k, then the value of the new determinant is k times the value of the original determinant. The value of the determinant remains unchanged if to each element of any particular row or column of the determinant, the equi-multiple of the corresponding elements of one or more rows or columns to be added or subtracted. See you in the next lecture. Thank you.